Hi, good morning, everyone. Or morning, maybe not more. Yeah, almost noon. So I'm Jérôme Vieilledent. I'm working as a product manager for developer experience at Platform.sh. And today I'm gonna present you a few things about observability. So what kind of observability tools we can rely on, and who's who, and yeah, develop what observability is about. Because, yeah, what observability is about sounds like a buzzword. And actually, this topic was around like for the last few years, but it became like a joining topic maybe in the last 2 or 3 years, at least for what I understood. And so I did my homework, and I went to Wikipedia to understand what was the overall definition. And yeah, we can say that observability is a measure of how well internal states of a system can be inferred from knowledge to its external outputs. And after reading that sentence, I had no more clue. But I have interesting highlighted words here, because it's talking about internal states, a system, and external outputs. So that's where it's starting to be interesting. Let's try to define all this and how it can apply on our daily life as an engineer, or maybe support engineer, or just a developer, or just, I mean, what can we learn from this? So first, I'm going to first highlight on the system part. We probably all know what an operating system is, but is this really what it is about? What is a system in terms of computer science? A system is a group of interacting or interrelated components that act according to a set of rules to form a unified whole. Thank you. I should have closed Wikipedia by now. But maybe it's all relative. It's a global definition. We know more or less what we're mentioning as a system. But to me, it also sounds like code. Different components interacting with one another, like, you know, these Symfony components lying around, used by so many frameworks in the PHP world, but also by the Symfony full stack framework, of course. We have business rules, algorithms, and maybe this unified whole can be the application itself we're implementing, we're developing. Let's keep that in mind. About internal states. This is literally the first picture I had in mind about all the internal states of a machine or whatever. And whenever an application is running or a machine is running, we know as engineers that we have all these components running continuously together. But yeah, it's relevant for most of these systems. But not only. That can be a web app, that can be consumers, that can be a coffee machine, an electric charging device, you name it. All these states usually can be binaries like OK or KO. Well, we're doing continuous checks on that. Wondering about how the machine is performing or the application is performing. So how does it perform actually? Is it good, bad, not so good, not so bad? So this is all what it is about. And also what we can learn from internal states is also errors, preventing the system to work as expected. That can be so different, right? Which lead us to the third highlighted keyword, which is external outputs. When mentioning external outputs, well, again, literally, that was the first image I had in mind, like this the LED screen showing random stuff. But what is important here is that it's something external to the system that is extracting information, key information, from the system itself. So from its own internal states, given to our knowledge. And, well, the output can be like the board from a Raspberry Pi, like that. But it can also, of course, be different depending on the nature of the system. And the information that is exposed to the user is probably the result of an action. For example, a JSON result from a web app, or just HTML code output, which is outputted to your browser. That can also be maintenance information, error code, system logs, right? Blueprints. Maybe we can think also about the blueprints before the system even runs, which to me is typically code before compilation, right? When I mean compilation, even in PHP we have a compilation to bytecode. So then, in this regard, the system is the project, and the output is the code. Right, so we have our definitions, but why do we need observability? Mostly because we want to learn from the states of our application. It's good for maintenance, it's good for to know how the application is performing. And when I talk about performance, I will go deeper into that. Performance as how fast it can be used, what kind of resource, how much resource it's consuming, because it's tightly related. And, well, why? Usually, not always, but usually we know this kind of cycle. From development to testing and staging and to production. And each environment has its own challenges. First, we want to prevent bugs. We need to debug, we need to improve, we need to validate through the tests. Once we've done that, we want to deploy to another environment and then do more testing, do more integration testing, end-to-end testing. And we need to decide if it is good or bad. And once in production, it's not finished. We can tend to think that it's finished. We're done. But we also have all the monitoring coming into place to identify and understand why we might have this issue when someone from marketing, the marketing team sent a newsletter or a social media campaign. At some point, we might have a big load on our servers running this application. So observability is the topic covering all this. And here I'm going to talk about 3 kinds of tools, but of course there can be many others. And again, about performance. You might have seen this slide during the Blackfire demos on the Blackfire booth. It is important because it's tightly related to user engagement. And what we know from real user research, that the web application's performance has really direct consequences on user engagement and thus companies' revenue. And not only for e-commerce, of course, e-commerce application services will have direct implication. And actually, these studies were done by Google, by Akamai, by Amazon. They're quite recent. The last one was done in 2017. So, well, it's 5 years ago. In my mind, I'm still in 2020. But it's still very vivid. And yes, that's true. 53% of users abandon a website after 3 seconds to load. End to end, from the request, from the click, to something that has been displayed on your browser. 3 seconds is nothing in a human lifetime, but this is the threshold where people start to drop and leave your website. And this, the last one, the last statistic is very interesting and has been raised by Amazon. They realized that dropping by 100 milliseconds, they increased the conversion rates by 7%. So that's what I like here, because taking care of performance, of course, it will help e-commerce or user engagement. And that's great, because performance also means less resources consumed and less carbon emissions. So this is personally what I like here. But control is critical here, and especially for automated systems. And, well, another fact, another slide that you can see during the Blackfire demos. The later you discover the issues, the higher will be the cost. So if you do not take care of performance as a feature, you will have to pay back at some point. Because trying to fix a bug in production, even this is like, not real numbers. This is just ordre de grandeur, right? So, but it will cost like 15,000 times. Oh no, I'm not good at math. Let's forget it. Much higher, much more expensive to fix your problem and discover it in production. While you might have been better at discovering it, at fixing it in development or in staging. It's better to discover something in staging than in production, for sure. But yeah, usually as developers, engineers, support people, we might not have the right tools to discover this and to be able to improve. Because you cannot improve something that you cannot measure. And yeah, we need to understand the root cause of our application. And this is what I'm going to talk about the kind of tools that we can use that are easy to apprehend and to understand and to use. So a typical system won't output its internal state out of the box. For many reasons. Because it needs to stay secure. And you probably don't want to leak information, sensitive information, to a client. And when I say client, it's mostly an HTTP client. And user output typically shows information that is relevant to the client. And logs should be properly configured, right? Which is not always the case. Oh, all right. With Symfony and in the PHP world, we do have this wonderful model log library and configuration, but we still need to pay close attention to that. We need dedicated and mostly external sensors or probes and services to be able to comprehend this. So let's get back to the blueprints, to the code. This is the first tool that is really important, in my opinion, in observability. Static analysis. We probably, who already use static analysis tools? I would say half of the room, which is not bad, but I'm sure we can do better. Well, code, as I explained, is the first output of a project. It consists in the blueprints of your application, and we have a lot of tools that are very useful to that. First, we can use the runtime itself, like PHP, using, checking for syntax errors. Maybe you can improve it with Xdebug to have like the whole call stack and so on, but that's quite limited. We can use linters. We can use code analyzers. So as linters, CSS lint, JS lint, etc., YAML lint, wonderful. But code analyzers like PHPStan, and I know Andre is somewhere, or Symfony Insight, which, by the way, can work with any PHP application, not only Symfony ones. And you have this in many, many other languages. Well, have you ever had a look at Symfony Insight? Well, if not, I know, I will talk about PHPStan in just the slide after. I want to talk about Symfony Insight because what I find really interesting in this product is that you not only have like these warnings, this is a potential bug, this is a potential performance issue, just by analyzing your code, like PHPStan does as well. But it also gives you an overview, an estimation on how long you can spend to improve your code and fix the issue. So, like this one, it says 5.9 months to get to the maximum, to get the platinum medal, which is usually overestimated. You might fix a lot of them just in a glimpse. Anyway, of course we have PHPStan, as I said, and what's really nice with PHPStan is that it's open source. It's not the case for Symfony Insight. But PHPStan also provides a professional service. The goal is the same, is to analyze your code and check, for example, if you are using variables that are not being declared beforehand. This is a potential bug, and that will depending on how your runtime, your PHP is configured, it might lead to fatal errors, or just notice that will be avoided because you configured your PHP for production, and so notice are not displayed. But you still have a performance issue because of this, because the PHP runtime did interpret the problem and did take care of it. All right, so that's for the blueprints. But once your code is running, I mean, within the runtime, you have your web server, which is running your PHP APM. Then your application, and not your code, we don't talk about code anymore. It becomes an application. Well, it becomes a black box, right? We are blind to what's really happening. You cannot see what's happening. And we can only use abstraction, mental abstraction, to guess how it works or why an error is happening. And okay, we can all do that, more or less, depending on our level of knowledge of the application, on the project. It's mostly okay for us as engineers because we designed it, right? But what about ops? What about support people? Or even users? they're not doing that. So how can we analyze what's going on in the black box? We can use logs. This is the famous log file from the moon ship that landed in 1969. So yeah, we can use that with log management, but logs must be properly configured with the appropriate verbosity. And it also needs to inform you timely. We don't want to go back and forth on the production server and check the log. I mean, that's really cumbersome, time-consuming, needs permission, probably a VPN. But still, if we don't use properly the appropriate service, like Sentry, for instance, for log forwarding, assuming that it's correctly, the logs are correctly configured, this is what your ops people will be doing, and they will hate you for that. And you will hate yourself as well, because you will have to also SSH into the machine if you have the permission, and check what was going on, and debug live. No one wants to do that. I mean, I don't. I've been there. I've done that. No more. Anyway, so yeah, Sentry for this is really cool. We start to have this kind of approach as well at Platform.sh. And yeah, please use them. That's so useful. We can also use infrastructure metrics. So this is just an example, very, very light example of what we can have monitoring containers on Platform.sh. But it gives you an insight of the resources that are being consumed. And you might see like bumps when your system is under load. But it doesn't say what's going on. It can send you messages eventually. But that's all. So then I want to get back to application metrics, because this is where it really matters. We need a probe for that. We need a sensor. So that might be the only real question that you might be wondering, or that your operation people will ask you, or security teams will ask you about. Do I really need this sensor? Usually the answer is yes, but we do need this to get an insight from the inside of the black box. So at the runtime level. We can also do that at the infrastructure level. This is what famous services like New Relic does, or Datadog does. You install many, many agents all over the place. But this comes with a cost usually. And I'm not talking about money, because yes, New Relic is also very, very expensive. So yeah, here I'm talking about monitoring, also known as APM, Application Performance Monitoring. But I'm also talking about profiling. So now I'm going to talk about Blackfire. So now it's been like a year and a half or something like that, that's Blackfire now also collects metrics as a monitoring system, monitoring service. So not only profiling. So what will the probe do? The probe will collect metrics from the runtime, which is on which your application is running. And when you're at the monitoring level, we're talking about traces. What a trace is like when a request comes to the server, to your application server, it generates a trace containing like the time the request was being used by your application to be processed, the amount of memory, and also a few information like the system load, and maybe the information about where in your application your trace is coming from. The good thing is that this kind of trace has a cost very close to zero. I mean, of course, you always have a cost. But when you gather these kind of metrics, which are really on the surface, the cost is negligible, really. But we have very few information. So that's why we also have extended traces. Extended traces are in the same mood, but they get a bit deeper. They will gather information about how your application is interacting with the database, for instance, so that we can have information on at the services. So that's what we call services monitoring, but directly from your application. So you don't need to have sensors on your database, which will slow down your database. So forget about that. We will then collect extended traces, and usually by default it's configured as like 1% of all the traces. So if you have like 1,000 traces coming in, let me do the math. Yeah, 10 traces will be will have extended traces. Thank you. So here we'll have global response time that's distributed over time, and we'll have like the 96th percentile, etc. So very statistics, very useful statistics there. But it's not sufficient. It will give you answers to two questions, which are written here. Not sure if this works. No, it doesn't. Which is, when and where do I have a problem? But we're still missing an important question, which is, why? And this is where profiling is useful. So, profiling needs to go much deeper. It will give you all the details, as much details as possible. At the function level, so this is what we have here. This is a dashboard for all the functions, what we call the call graph. Each box represents a function call or just a group of function calls, and you have all the details on how much resources it has consumed, function by function. So you will easily be able to spot where in your application it was, I mean, at the function level, it was a problem, there was a problem, and help you understand why you had a problem. So let me take a metaphor, because we're close to Paris. So traffic city scale, live, which is not really realistic because it's all green. But anyway. Let's pretend it's like in the middle of the night. But this is monitoring, right? Let's pretend that it's monitored live. So you would see there the traffic evolving real time. This is the overview that monitoring will give you. You will still see if you have issues like on this, on that road, on the west, near La Celle-Saint-Cloud, we have like a big traffic jam. So we know where. Monitoring here, thanks to these traces and identification that are also named transactions, will help you focus on this part, and then we can give a better focus, like this. Here we are the extended trace. We can better understand what's going on, focusing on this area. And okay, we can see that we seem to have a road that has been closed. Okay, but it doesn't say why we have this road closed, why we have this traffic jam. Maybe there was an accident at some point. And the profiles will give you the street view. and the sign saying that this road is closed. I said, I'm still in 2020, so that's why the future in 2021. Yeah, okay, we're doing road surface renewal, etc. So great, I have detailed information. And last but not least, what can a profiler like Blackfire do is give you actionable performance insights. Because you're not always having a look at your monitoring dashboard or always doing profiles. This is why you're paying a service for, usually, to do that for you and inform you timely, send you notification on, hey, your application is under heavy load at that, and that part might be problematic. This is why, this is where you will find these kind of things. So with the most impactful transaction, which one were degrading gradually? So sometimes you have issues that are just under the radar. You don't see them coming, but the transactions are getting slower and slower, but you don't see them. So here, Blackfire tells you gradually degrading transactions. So yeah, this post action is kind of a problem. You should fix this. But also recommendations based on the profiles. So when you have all these three plus the first one, the code analysis, when you have these three joined, you'll have a almost 360 degrees view of your application, live. And here, of course, it's production, but you can also use, and you should actually, use a profiler also in development, because it will help you understand, why do I have this bug? And also, why do I have this bug in production that I cannot reproduce on my local environment? Who already experienced that? That's what I thought. Yeah, so because you can compare as well. So that's really, really useful. So that's all about performance and also not performance, sorry, observability. It's important because performance and stability matters, really. Think about performance as a feature. And also, keep in mind, that's maybe the main takeaway here, that performance is only an aspect of the behavior of your application. It's only one side. It's important, of course, but it's so much more. Thank you for your attention.